Well, thanks, Chuck. It's a pleasure to be here. It's a Friday morning. Hopefully everybody's still got a little energy left. I want to try and make this very interactive. So if you have any questions, comments throughout the way, please stop me. You don't want to let me drone on for an hour plus here. This is going to get kind of mundane. I was asked by Sid Brantley to kind of talk about climate change in general terms, what's going on, weather variability, and how do you talk to producers about this. And as Chuck mentioned, as of February, actually yesterday was the year anniversary of the Secretary of Ag, Vilsack, announcing the USDA climate hubs. And so we are ARS, and myself as the director of the Northern Plains Regional Climate Hub out of Fort Collins, collaborations with Forest Service, Linda Joyce, and then from NRCS, Rafael Guerrero, who's out of the Fort Worth Technical Shop. So that kind of core group is leading the charge. We'll showcase some of kind of what we're doing there, and that's kind of still in its infancy. And then in my real job, which I really get paid for, this rangeland scientist and research leader for the Rangeland Resources Research Unit out of Cheyenne, Wyoming, and Fort Collins, Colorado. We'll showcase, again, some results and some stuff we're doing there in terms of grazing lands and climate change. I think for this discussion, I want to kind of start with some general sideboards so we kind of know where we're going and kind of why this might be important, and maybe give you some context to what's going on in terms of how you shape conversations when you visit with ranchers and producers. You know, it's pretty clear if we look at this one, this is kind of the big elephant in the room in terms of there's a lot of population. We're going to 9 plus some number billion by 2050. A lot of that growth is going to be in the tropical environments. And there's a lot of increase in animal protein. So this has ramifications for how do we do that on rangelands, right? So how do we ramp up production? How do we sustainably intensify production is a big word out there. Producing more on less, but doing it in a way that's at least neutral and perhaps positive then to the environment. And we know that this is ongoing as well. So we've got increased greenhouse gas concentrations. And I'll showcase CO2 over here. Back before the Ice Age, and it continues to go up when we just passed 400 parts per million. That has tremendous implications then on what's going on in terms of plant communities, plant growth, forage quality. And we know from a lot of the work we've been looking at in semi-arid rangelands, CO2 is very good in terms of water use efficiency. The higher CO2 you get in the atmosphere, the less water the plants have to lose because the stomates can be more closed, and then that way the plant gets more plant water use efficient. So that's a good thing, we think, right? The problem is that our native plants do this, but the, quote, saved water, the excess water that's not used, is used by a lot of invasive plants. So water spenders, if you will. So in our case, invasive plants and perhaps other trees, eastern red cedar and so forth, are using that water and essentially then shifting the plant composition because they become much more competitive. So in our case, in the northern mixed grass prairie, western wheatgrass, needle and thread and so forth are very efficient in water use efficiency, but when we save that water, other plants come in. And a lot of those are deep taprooted forbs, such as spotted knapweed, leafy spurge, Dalmatian toadflax, and they essentially blow that water, use it, and that becomes problematic for us. The other big key is forage quality. So anytime you add carbon to the atmosphere, right, there's only so much nitrogen in the soil, your carbon to nitrogen ratios are going to change. As we increase in this carbon dioxide range, clear down here at 280 up to 400, predicted to go to 550 by the middle of the century, perhaps 700 parts per million by the end of the century, tremendous changes on the forage quality. So we may be producing more biomass, right, more forage because of plant water use efficiency, more growth. The problem is it's going to be low quality, and most of that stuff on the rangelands is already marginal in many cases. So now we've got a situation where we're producing more of less quality. What are we going to do in terms of how do we target grazing to ensure that we're getting adequate forage quality at the time, or some sort of supplementation, which can be expensive, or changes in the plant community, perhaps the introduction of legumes or so forth, to get us past this kind of problem area in terms of forage quality. Any questions about that? Because I think that's a major thing that we're going to come back to and talk about is in terms of forage quality of livestock producers. There's some real problems we're going to run into in rangelands here, especially in semi-arid and arid parts. So organize a conversation for this morning. I kind of 4 major areas here. And I really want to talk about what do we know about drivers of grazing lands in pretty general terms. We'll showcase weather and climate, how that influences management as well as conservation issues. We'll look back and what's recently happened in the past, kind of give some context, why we're talking about this, why it's important. And I think when you visit with producers, we'll see some nuggets of information that come from them. We'll take a little look into what might be coming down the road, middle part of the century, longer term projections. What's that mean in terms of things, in terms of directional change, much like atmospheric carbon dioxide, increased variability, extreme events, and then we'll talk about spatial differences. Climate change is occurring, but it's not going to be universal across the entire North America. And then I'm going to come back and try to say, well, how do we look at this in terms of conservation practices and management practices? What sort of things can we do looking at management? So we got to be flexible. We have to be adaptive. How do we do that in terms of drought, enterprise structure, grazing, technology monitoring? There's a lot of cool things out there. How do we start to put it together, package it, and make it something that a producer is going to utilize on his or her ranch? So if we look at drivers for grazing lands, we know that most of these systems developed under some sort of large herbivore grazing. Could have been bison, elk, or whatever. Largely been replaced by livestock of some kind, cattle, sheep, and so forth. And then we've got, in many systems, drought. So we've got the Dust Bowl years of the 1930s. If anybody's read The Worst Hard Time by Timothy Egan, you know, a fantastic chronology what happened there in terms of both ecosystem response, but also I think the social human responses as well. So we look primarily on the Great Plains. I'll use that as an example since that's kind of where most of our work is. You know, we've got two major gradients. We've got temperature and we've got precipitation. And so those sort of biophysical drivers influence what sort of plant communities we have, what sort of production we have. We look at kind of the Rocky Mountains coming down here. We're in the rain shadow here, very dry environment. So we're looking here about 12 to 13 inches of rain here. Rapidly, those who move across into Kansas, you know, we can get to 40 inches of rain by eastern Kansas. So a tremendous environmental gradient just in this short time period. And then we're also looking at a tremendous temperature gradient from northwest to southeast. Right? So in general, we've got hot, humid down here with a lot of precipitation, dry environments, and then a cooler but moist environment here. Again, we've got some sort of livestock or large herbivores been a driver on it. We've got fire, again, probably more predominantly in a tall grass prairie, but we know these systems evolved under some sort of fire regime. And then drought. So this kind of chronological history of what happened the last 100 years in terms of drought severity. The darker the colors here, so dark reds, are you're in drought, severe to extreme drought, 15 to 20% of the time. It shouldn't be a surprise that we have droughts, right? But it seems like they sneak up on us and we're always having a reactive manner. Texas is undergoing a major one, southeast Colorado still in one, and now of course out here in California, a tremendous amount of drought. But historically, if we look back at this sort of diagram, we know some areas that are very prone to drought, and as such, how can we implement that into our planning down the road, especially as we have increased climate variability? So this looks like probably any place in the world you could look at in terms of rangelands, in terms of interannual variability and precipitation. Just happens to be one of our research stations in northern Colorado. And we've got annual precipitation here in millimeters. Divide that by 25 and you get down to inches. From 1939 up to just finished up 2014. Right? So here we are looking at, what do we look at in terms of averages? Right? So here it is, about 341 or about almost 13 inches. The problem with that is nothing's hardly ever average. I think there might be a couple years in there where it looks like it is, right? But we have this tremendous amount of variability. And here we are as a rancher or conservation organization, whatever it might be, trying to manage landscapes, ranches, in this sort of really variable context. I'll give you an example here. 1964, we're clear down here. 2 years later, clear up here. That sort of variability is really hard to plan for. So how can we be adaptive? How can we be flexible in terms of stocking, in terms of our management operation? And can we take advantage of this rather than always being reactive to it, trying to always say, oh my gosh, it's dry, we got to sell animals, move animals. Oh my gosh, it's wet, what do we do with that excess forage? So how do we take advantage of that, knowing that that's really the game we're playing right here is interannual variability. Now, if we look at regular spring precipitation, so in our area, spring really drives those cool season grasses, which we need for production. Same sort of thing. We're bouncing all over the place. Really wet springs, dry springs, back and forth. So again, this is really paramount. What kind of things can we use for predictions? Right? We don't have a very good idea what prediction for the spring might be, but we know it's important in terms of forage production. We've got a lot of uncertainty in the system, and this is a real management challenge for us. And then you get to something like this, and you go, oh my gosh, what's this guy doing? But take a little bit of time here and look at what an annual year might look like for a rancher in the system. So let's say you're in, again, northeastern Colorado. The bars here represent normal. Right? This is average. Right? So nice kind of unimodal. That's the type of thing we say, well, if you're managing for a ranch, is that what you would do? Manage for the normal? Notice it's got a lot of variability just inherent within that. But then we look at, this is the minimum, the red is. So in almost any given month across those 70 plus years, you can have 0. Right? So that's a pretty good chance. It could really be bad. The blue line here is the maximum that's ever been recorded in that month. And you're like, wow, you know, here's the average. Ooh, it could get really wet, almost 7 inches. How do we plan for that sort of variability? What do we do if we're in a management situation and we get that sort of variability? And this doesn't mean that it's going to stay nice, because it could go here and it could drop back down. This is 2013, just for one example. We had a really nice early spring. June dropped off, got hot and dry, and we really were in some management considerations there, what we're going to do. And it popped back up in July and August, and so it was a pretty decent year. And then it rained good in September. But again, this is kind of driving home the point of we've got really variable systems, right? Just in terms of precipitation, we're going to show some other things. But how does a rancher manage this sort of thing? What sort of planning goes on to help utilize this in an adaptive framework? So this is really reality you're dealing with, the reality ranchers are dealing with, the reality the researchers are dealing with. We sit there and say, man, how do we deal with forage production? So this is some data actually at Cheyenne going back to 1982. Again, the average production up there is about 1,250 kilograms per hectare. And if you look there across, all right, so I'm a rancher. I've got a piece of ground. How many cattle do I stock on that place? Right? Do I shoot for this sort of thing? Do I drop it a little bit? How do I take advantage again of this? Right? So this is a bad year. Up, down. 2001, man, really bad. 2000, really bad. 2001 is about a 50-fold increase. And you think, oh my gosh, we're all right. Oh, 2002, right back down. All right? We're playing this kind of seesaw game. So this is really a problem when you look at management plans. You look at what we should do in terms of residual stubble heights. You know, how do we get sort of wildlife habitat melded into this? What if we want to do some other rangeland improvements? What if we want to do something in terms of carbon sequestration? This is just trying to play with us. So one of the things we have to look at is, can we get some sort of predictive relationships that say, how much guesswork can we take out of the system for the rancher? Right? Because we don't really do very well in terms of predicting precipitation. So can we give that person a tool or two to help them? And so, yeah, we've got some pretty good tools out there. Looking at the same long-term data, we can predict with spring precipitation, if we take total April, May, and June, we get some pretty good regression relationships. You know, R-squareds of 0.5 to 0.6, pretty decent predictive ability, saying if we know the precipitation, we can tell you what the production is going to be. Well, this is great, but this is all hind forecasting looking back, right? If I got a rancher sitting in Cheyenne when I get back home, and he says, all right, what do you think we should do for 2015? I'm like, what do you think the precipitation is going to do, right? If we knew that, right? If we knew this, if someone could give us some pretty decent current spring forecasting, right? Not just a guess, but actually something that's pretty refined, that kind of took the risk out of it, then we could start to say, listen, we know that it's going to be about 200. Okay, so which grazing system, what stocking rate? We have a pretty good ability then to predict and start to make some management planning. And then until the weather forecast and NOAA and so forth can give us much better predictions, this is going to remain essentially just a coin toss. Now there's some things we can do. We know that the following fall, or the earlier fall moisture was pretty good, so we've got some residual soil moisture coming. Winter's been a little bit dry and warm, so then, that's a negative. At what point, though, is you as a producer going to have to make a management decision on where this sort of stocking decision is going to be in terms of ultimate forage production? Or are there some changes you can use in your enterprise that gives you a lot of flexibility up until about April 1? Right? And we'll talk about maybe some of the structural changes in how you have a cow-calf yearling operation that might be advantageous in situations like this. Not only that, but in our system and many other rangeland systems, you got different plant communities out there and they respond differently to when the precipitation comes. So let's set the stage here. Again, we're in Cheyenne and we have a light gray system. So this is dominated largely by our cool season perennial grasses that really respond to early spring precipitation. We get a lot of good forage growth. If we have moderate stocking rates, we kind of got a mixed C3, C4 grass community of, the western wheatgrass, the Neeland thread, and then our C4 blue grama thrown in there. And if we have a historical heavy grazing treatment, which is largely shifted much more to a short grass looking system, we have a lot more blue grama, then we're into where June precipitation really drives it because it's a warm season plant and we're waiting on later precipitation. So how do I know what that ranch looks like? Well, I know what my plant communities are, because if I got a lot of blue grama rangeland and I get rain in April, it's okay, but it's not driving the sort of response I'm probably going to need. If I got a system that's got a lot of cool season grasses and I don't get a good April, guess what? I'm in pretty tough shape then, and so I need to make some management decisions come May and June because I'm probably not going to get the forage growth because I didn't get the early spring precipitation. I think here's another thing that we've, as rangeland scientists, have not done a very good job in transferring information to land managers, to practitioners. We would think, listen, if it rains more, livestock gains ought to be better, right? And if it's dry, livestock gains ought to be poorer. Well, one of those two is correct. And it's not what happens when we get, so this is some long-term data, 70 years down in Colorado, different stocking rates, and looking at if we have a wet year. This is kind of an average or median year. This is if we have a dry summer, and this is a dry spring with a dry year, so really dry. And those don't occur that often down there, unfortunately. But what you're seeing here is some really interesting information. We just take the middle years, these kind of light gray bars. This is our average response in terms of essentially pounds of beef per acre. Heavy, moderate, light. Of course, you get more with heavy because you got more animals out there per unit area basis. But when it's wet year, we get a little bump, but not significantly different in any of those grazing treatments. Right. What the heck? We got more water, we got more forage, we're not getting more livestock gain, we're not being able to take advantage of it. When it's dry, we're seeing a pretty significant reduction. Right. That's usually what happens. Most of those producers will tell you that's what's going to happen. Now, if it's dry during the year and a really dry spring, wow. You want to take this versus this versus this versus this, at $3 or $4 a pound for a calf out there, that's a lot of economic ramifications for a producer out there. So really, I think what this is telling us that in those really good years, we're not making a whole lot more beef production out there. Right? So we're not stocked at the ability to be able to take advantage of it, first of all, and the system's not responsive enough in terms of giving us an extra boost in terms of individual livestock gains or gains per unit land area. But when it's dry and forage becomes limiting, we're seeing some real negative reductions both in dry years and dry springs with dry summers. So this sort of thing, as we look at climate change and projections, has tremendous implications, again, to the bottom line for ranchers. What it says to me is, in the good years, we're not going to get an extra bang for the buck, but in the dry years, this might be when we really get in the jam in terms of financial consequences on the land management, on the ranch right there. So how do we, again, reduce that risk for producers? Because these are the sort of things here, if these happen 1 year in a row, maybe you can get by. 2 years in a row, well, it's a tough situation. If it's 3 or 4, guess what? You're probably looking at selling a ranch, doing some other sort of business. This is really, I think, has some implications for rural economies and what we do, and how can we reduce this sort of risk here in terms of management flexibility. Okay, so what's happened in recent past? This looks like Chuck's country, right? Looks like good rangeland management, right? Doing everything right. Still some green plants. So I think one of the things to realize when we talk to producers about what's going on is what has happened in whatever area you happen to be in. And some areas will showcase there's actually been some really good things happen in the last 10, 15 years, and boy, they think things are really going well. You go down into Texas, parts of Oklahoma, southeastern Kansas, man, the world's falling apart. This is what it looks like, right? So we're in tough situations. Drought's really hitting us. Talk to the California producers and the same sort of thing. So what recently has happened is shaping the context of the management decisions and maybe is a little more influential in their mind than perhaps it could be if conditions had been different. So this is largely summarized, came out in May. The third National Climate Assessment was put out. If you just Google that, you can go to it. It's a fantastic report done at the U.S. level. Really, I think, captures the information in a very good manner and will showcase a lot of graphs and slides just to kind of give you some areas to go to. And it's all downloadable, all available. It's a really nice aspect. But really what they're looking at in terms of this is droughts, downpours, and extreme events, right? So this sort of increased variability at the extremes. The old bell-shaped curve is having a bigger tail on both ends, right? Dry and wet. So we're dealing with situations where we get droughts, right? We get some hailstorm events. We get a downpour that might have been before really a precipitation event we don't have much experience with. 4, 5, 6, 8, 10 inches of rain. That has tremendous implications in terms of soil erosion and loss of capacity. This is a gruesome photo, unfortunately, from the Atlas snowstorm up in western South Dakota. Freak snowstorm event in early October, right? Killed 30,000 plus head of animals up there just because of the timing. One of those weird things. And this happens to be a photo, actually, of our research station, again, that gets about 12 inches of rain. Who would have ever thought that you could have a canoe and be out floating around on that, right? So you get a downpour event. It happens in a very short time period. You have a lot of water that moves on that landscape. How do you manage a landscape that has this sort of variability among it, right? And if this is what the new normal becomes, really we need to shape what our context is instead of saying, well, that was a once in a 500-year flood, or that was just a pretty tough year drought, it's going to get better. I think this is an interesting graph when you look at the 1990s to current and compared to the early part of the 1900 and 1960. Provides, I think, some context of what we've seen go on in terms of agriculture. So on this case, let's set the stage here. So if it's the darker the green, the better it's getting. So this is precipitation above what fell in the 1900s to 1960s. Darker greens, 15% increase. You get down to the darker reds, 15% worse. Okay, so this is about the last 30 years relative to what happened before that. There's some interesting spatial trends out there, right? So again, when we talk about what's been going on, it's not universal across the way. We see this desert southwest, right? Dry, it's getting drier, right? Some pretty good data out there showing that. California has been relatively wet over that time period. Look at the Great Plains here, especially on the eastern side. The new normal, if you will, from the management context of producers who've been in that situation for these last 30 years are, hey, it's wet. And this is different. I mean, we're now growing corn, soybeans, a lot of stuff in eastern South Dakota, eastern North Dakota, moving up into Canada. Is that what we're going to experience in terms of the benchmark knowledge of the producers? And when it gets dry, or if it does return back to, quote, what used to be normal, what's going to be the ramifications here, right? So this is kind of an interesting thing that I think that sets the stage when you go out and talk to the producers. What's it been like the last 10, 15, 20 years? Boy, when you go talk to folks over here in this part of the country, it's different. It's wetter. They know it's wetter. They're tile draining areas in eastern South Dakota, right, to get the water out of the way. Or they're putting cover crops in just to get rid of the excess water so they can plant the following spring. Yes, it's in the report. Yep, and I'll show a little bit of it, somewhat, but most of it is the distribution is largely staying the same, but it's bigger rainfall events and more of them. And then it's broken down by the regions, and you see here, the Great Plains, Alaska's really no trend, Northwest, and Hawaii, if you look at, if you want to look at a dry area, Hawaii has gotten relatively drier. So that's what they tried to do in the report, was break it down by kind of groupings of states, and then you can further drill that data down and look at what's going on within a smaller region. But I think this has some really interesting things in what we think the long-term normal was, and really what the ramifications of the last 30 years are in terms of folks here, have been dealing with drought, and this sort of kind of almost artificial increase in precipitation really changes how we manage many parts of the eastern part of the Great Plains. So here's a little more distilling down on that. When you look at that precipitation coming in, what they call very heavy precipitation, above a couple inches here, relative, again, back to that same sort of timeline. And the change here is on a little bit bigger scale. So the darker it gets, 40 plus change in heavy rainfall events, or these downpours, right? I can remember growing up when it seemed like you got a 3 or 4 day rainfall event and you may have got an inch and a half. Now it's not uncommon to look at the weather report in the morning and say, my gosh, they got 6 inches of rain over here, and this place got 4.5, and that might have been a third or half of their average. So that's sort of, I think, of downpours is starting to become more commonplace. If they kind of group the desert Southwest, Colorado down, not a whole lot of change in terms of downpours down there. It's also been drier than average, though. Great Plains, here about 16% increase in downpours or heavy rainfall events. So again, on rangelands, do we have enough vegetation cover? Are we looking at enhanced soil erosion? On croplands, do we have this, again, the same sort of cover? What are we doing in terms of no-till? And really, when you start to look at the implications for crop production, when you move into the Northeast and the Midwest, those areas have experienced some marked increases in downpour events. Right? So again, you're looking at potential losing water, or you losing soil to erosion, this sorts of things. And of course, this has ramifications here in terms of water quality coming down to the Gulf. So those sorts of things, again, are pretty well documented here, and again, kind of shapes maybe the last 30 years of management by producers in these areas. So now we look at temperature. And so here, if we're looking at light shades of blue down the kind of southeast, this is not much change, or actually cooler. Anything red and darker the red, more temperature, higher temperatures, up to about 1.5 degrees Fahrenheit in these dark red areas. So again, 1990 to current versus back 1900s. And if you look across most of the U.S. in general, clear indications that we have increase in temperatures, again, minus maybe this part of the southeast, and a lot of increases in temperatures across the Intermountain West. A lot of these in mountainous areas. Ramifications there are less snowpack. Snow melt coming off earlier, right? Rain instead of snow when we're increasing elevations and when that snow occurs. And this is having some things we'll talk about later in terms of growing season and so forth. But across, again, pretty universally across all these regions, much warmer over the last 30 years than in history in the past. So I think, again, putting that together in terms of when you visit with ranchers, asking them those questions. What's it been like? If you can, especially if you can get some generations back and say, well, yeah, maybe in the 50s and 60s it was this way, and now we're seeing more extended droughts or different types of droughts or more heavy precipitation. Once they start to understand that things are different and that kind of new normal is emerging, one of the considerations they'll have to say is, what sort of experiential knowledge do I have? Right? Is it the same drought my dad had? Is it the same drought my grandpa had? Probably not, because things are changing. And so how do we manage when we don't really have that kind of baseline or benchmark event to go back to? And so this, again, pretty clear evidence here in terms of lengthening of the growing season. Right? So the increase in frost-free seasons. Desert Southwest and most of the West Coast, you're talking 2 to almost 3 weeks of a longer growing season over the last 30 years. Right? So that's earlier in the spring getting warmer, going through later in the fall. So that's tremendous in terms of the water availability, the water use. Again, in the Midwest or Great Plains, about a week and a half, a little over a week, and roughly a week to week plus on the East Coast. You've seen the USDA plant hardiness zones change, move north, right? So anybody who does any sort of gardening and so forth, you're now buying probably a different plant than you would have 10, 15, 20 years ago. And projections are that's going to continue to move further north. So if you're planting trees now, you should be looking, one hardiness zone south. But this, again, if you talk to producers, comes through pretty clear, right? When you're going out on your grazing. Well, I used to go out maybe June 1, right? Because Grandpa always did. But now it seems like the grass is greening up earlier, right? So they know these sorts of things are going on out there. They don't have to be hammered over the head that it's climate change. It's an ongoing thing. It's a directional shift. We can just continue to see this get longer and longer. We'll showcase some pretty scary graphs here in a minute in terms of the end of the century. But they know this is going on, and so they're adapting maybe some of their management to it. If they can, if they have the flexibility on private lands. I think the public lands, again, there's a problem there because sometimes allotments are fixed when you can go on, and we're having some issues trying to change that to get in accordance with this increase in frost-free length, increase in growing season, and take advantage of that forage quality when it's there earlier in the season. Yes? Well, for groundwater recharge, yeah, so a tremendous amount of concern in the Ogallala Aquifer right now, right? So you take this area here from Nebraska down, we already know just from the increased pumping demand and irrigation capacity, several of these areas are in major deficits, using more water than there is available, not being able to recharge. But the only areas, if you look at the USGS data, that's actually recharging is, of course, the Nebraska sandhills, given the soil texture. Right? So now we're looking at a situation where snow is coming off the mountains earlier. Right? The reservoirs are filling up earlier in the spring, and we have more evaporation before we get to actual crop production. And instead of maybe getting snow across this sort of thing, it will be a slow infiltration in the spring, we're going to rainfall events. And instead of a 2-inch rainfall event that would soak in, infiltrate, and then recharge, we're going to 4 or 5-inch rainfall events. How much of that is getting into the soil? How much is that's running off? Right? And of course, soil texture is going to be a major player there. But these sorts of areas here, when you have very dry soils and then you dump 4 inches of rainfall on it, I mean, it doesn't take a rocket scientist. It doesn't take me as a non-trained soil scientist to be able to sit there and say, that's not a good thing. We just can't get enough cover on that to slow down that water. We know we're going to have some sort of erosion. Now, whether or not it actually runs off and comes to the bay, comes down, or are we running off to somebody else's property then stored someplace else? But clearly, soil movement is going to happen on those sorts of things, and that's a major thing of we've got to look at what kind of cover we're going to have out there and when we need that cover, right, in terms of rangeland. So we've got to be pretty careful in ensuring that we've got some sort of something out there to at least intercept that rainfall because it's coming at a much higher intensity and a shorter time period. Great question. Anything else on this? I like the interaction questions. So we kind of looked at recently what's happened. I think the producers, again, and when you start and visit with them, they understand what's going on. They kind of understand it in terms of their context. The real uncertainty, though, is, so what's going to happen forward, right? How much confidence do we have? What's really going to happen? What's going to happen in my place? And how fast is it going to occur, right? Are we talking about their generation? Are we talking about the kids' generation, grandkids, so forth? So the National Climate Assessment put these out for about 2060, 2070, so 40 plus years in advance. Some pretty, I'll call them scary looks at it. I mean, these are things that we really need to get a handle on now in terms of management on these rangelands. This is soil moisture. Again, brown's bad, green's good. Look across these in terms of mid-century changes versus end of century. There's not a lot of green up there. There's a lot of brown, there's a lot of dark brown. Okay? So by 2050, we've got a lot of rangeland in here that's going to be experiencing 10 to 15% less soil moisture. It's already, most of that's a dry system. We really rely on soil moisture. If we're reducing soil moisture, we've only got a couple options. We've got to hope that carbon dioxide continues to increase, right, because those plants are water use efficient. But are we looking at balancing off that with forage quality and it playing a net sum game here? We look at the end of the century, and again, darker and darker, and only really in the Pacific Northwest and a few scattered spots does it appear to be that soil moisture might be enhanced. Again, these are projections. There's a lot of uncertainty in this, but I think it gives you some spatial patterns where things might be bad. My guess, if I look at this, when they got pretty good confidence it's 15% below, even if you're off a little bit, that's still a dry environment. Right? If I'm in these areas here where it's a little bit in the middle, things are probably not going to change much because we don't have a lot of confidence. And if we have some pretty dark greens, perhaps that's areas that I have pretty good confidence in that those sort of soil moisture changes are going to actually be enhanced. But again, not everybody's going to be done the same. You've got some states here that are really variable. Utah, Nevada, parts of Idaho, drier or wetter. Context is going to be clearly important here when you go out and visit with producers. It's not just, oh my gosh, it's going to be hotter or drier and everybody's going to be in the same perilous situation. This is large, the soil moisture here. So largely a couple of things relate to that. One, warmer, right? Longer growing season, those two. And then the lack of that water actually getting infiltrated for soil moisture and moving off-site. Yep. That's right. And I think what we're seeing, because of that, we're seeing droughts feed upon themselves. Right? If you look at the drought monitor and a drought starts to emerge somewhere, it starts to spread out, it's dry, the areas around it become hotter and drier, the atmosphere just doesn't hold that moisture, and you kind of get that bubble, if you will, around you, and it just, we're not getting that consistent rainfall to come in and have at least a breakup of the drought. And so some of the droughts we're seeing now are much longer, more intense. I'll showcase some data on the more consecutive dry days. Those sorts of things, again, really influence plant growth, plant regrowth, if we're into some sort of rotational grazing system, right? And we're moving through pastures with the expectation that we could come back, and we graze them off and it stays dry. What do we do when we get to the end of the day and we got no place to come back? Right? So those sorts of things, I think, are really impacting rangeland management. Here we are looking at a series of 4 graphs similar to what we showed before. So this, again, middle part of the century, and projections for change in frost-free length. So darker becomes more days. So again, extending the growing season. This is the number of frost days. Darker is less. So these two are essentially inverses. Right? Take a look at that and just think of the ramifications for not only rangeland management, what about water supplies for major cities in the West? Denver, Salt Lake City, Las Vegas, Phoenix, LA. When you look at increasing days without frost and decreasing days with frost, something's got to give. Right? You're not having snow on the mountains, you're not being able to hold it there, you're not being able to keep it there at the right time and get a runoff at the right time. This has huge implications well beyond rangelands in terms of social, economic, social, public health issues, and really political aspects here. This is what I was talking about before with this dry days. So how many dry days in a row more will we start to have? And so the darker it gets, we get up towards about 15 more days of dry periods, no rain. Right? So we're extending the dry periods without getting some rainfall events to perhaps recharge soil moisture, keep plant growth going. This is a lot of change here. We're looking at anywhere from 9 to 15, lighter brown being 3 to 4, more days where it's drier. And you think, well, that's not too bad, right? But add 3 more days where it's dry. A couple of things here to look at in this one. There is a bright, if you're up here in the northern plains, you're essentially at 0 or perhaps even having less dry days. right? So again, I think one of the conversations we have with producers is it's not always going to be a detriment to your operation. It depends where you are spatially. This is one that really scares public health in terms of hot nights. And this is 70 to 80 days more of hot nights above 80 degrees Fahrenheit. So your electric company, how do you produce enough power to how to do that? You know, elderly care, we're talking about folks in these areas that are already stressed in terms of human health, and now we're going to add 80 more nights of hot nights. So what we're seeing in terms of temperature is the daytime temperatures aren't really going up. It's the nighttime temperatures that aren't coming back down. Right? So it might get to be 102 degrees, and typically we cool off to 68. We're cooling off to maybe 75, 80, especially in these urban areas, and that's producing tremendous amount of, you know, stress on animals, stress on humans, stress on plants. What does this do for corn yields, right? Especially when we're starting to look at when we need to get that thing pollinated. What are we doing in terms of livestock management? You're going to put your bulls out there, and guess what? It gets nice and hot during the night. What are they doing? They're going to be laying around not doing their job. So what sort of things are we doing in terms of reproductive physiology? We're going to have to maybe change our breeding seasons to take advantage of when we might have cooler nights. But this has, I think, some really implications for water management, herd health, and human health, and so forth. So please take a look at these. Again, if you ask questions, we can come back to these. But these are things I think that perhaps provoke a fear in producers when they look at this. But please realize, again, these are down into middle to the latter part of this century. It's not going to happen overnight. Right? We're not going to walk out there in 2020 and go, "Oh, we just jumped." But it's going to be a directional and a pretty good trend shift that we'll see these sorts of things occur. So you think that was ugly? Let's look at precipitation. And with the caveat that it's a pretty good data set that really has the temperature data. Precipitation is harder to predict, just in general. There's a lot more things that get in the way, like mountains and jet streams. But this is kind of the best predictions they've got now in terms of looking at seasonal aspects of precipitation. So this is getting back to, again, that question of, so we know it's going to get more intense, but what about the seasonality of it? And what sort of shifts are we going to see that might influence native plant communities, again, forage reserves, and so forth. So we'll work through this kind of simply. Let's take winter precipitation. If you just want to draw the general argument, northern half of the U.S. and Canada, you're going to get more moisture. And especially the further north you're going to go, you're going to get more, 20, maybe even 30% more winter precipitation. Is this going to be snow? Who knows? Depends on how the temperature is, right? But it's going to be snow or rain, some sort of increase in precipitation. If you're in the desert southwest and then Mexico, you're dry during the winter, you're going to continue to be drier. Right? So there's some real spatial gradients here in terms of what the models predict in terms of winter precipitation. And you're sitting there thinking, well, winter doesn't mean all that, a lot of our rangelands. Yeah, it does, because that's where a lot of that snowpack's being generated to help hold up water for reservoir management coming into the spring for associated crops, hay crops, and so forth. So if we move into the spring, we see a general similar pattern going on. Again, the northern part of the U.S. and Canada, enhanced predictability of greater precipitation. But we see this dry area move further north and northeast. Right? So again, implications for much more of our rangelands, especially Intermountain West and the southern Great Plains, where this is pretty good country here we're going to need for wheat. Right? So what's that going to do in terms of our ability to graze wheat in that area? What's that do for the stocker performance coming out of there? There's a huge amount of cattle coming from the southeast coming here and then going up either onto northern rangelands or into feedlots. Does that change the enterprise structure of cattle in that country? And then summer. And summer is kind of the hodgepodge one now that we're looking at. Again, northern Canada looks all right. Most of the U.S. during the summer either is going to be similar or drier than average. In some of the areas, looks like, again, predictions much, much drier. Northern California up through the kind of Palouse. I mean, this is pretty strong evidence to me that this is going to be a tougher situation during the summer. And you see this sort of thing in the southern Great Plains. Sorry, Chuck. But I think we're starting to see some things emerge there in the southern Great Plains. We're just not going to get that Gulf flow moisture coming in there. So again, this has ramifications of how we manage these sort of systems. And then we look back to the fall, and again, the general pattern is northern Great Plains on up, southern part drier. So to me, you put a rocket scientist together with me, and two of us, maybe we could figure out what's going on over the total aspect. All right, so it looks like to me, if you're in the northern Great Plains, winter and summer is going to be pretty nice, along with fall. Concern's going to be summer. What's going to happen there? We know that's a major period of growth in that northern Great Plains because it's already cool, and we rely a lot on cool season grasses during that time period. If you're ranching in this sort of the country, huge amount of probability that it's going to be drier across most all of those seasons, and that has implications for management down there. And then if you're kind of caught in this swath in the middle, right, that's where kind of most of the uncertainty is. So how do we manage in these sort of systems where it could go either way? And hopefully the models will start to show us some more definitive timelines and more spatial aspects of that. Because right now that kind of seems to be the zone of where the uncertainties really come into play. Questions on this? Because I think this is another major thing that we talk to producers in the field. You know, one of the things that we're very fortunate in the Northern Plains is it looks like we might be a winner here. Right? If you want to put winners and losers to this, the Northern Plains is going to get some nice precipitation, maybe other than summer. And if you want to talk about, quote, losers, if you will, or those are going to be facing more negative aspirations, it's going to be that desert Southwest, Southern Great Plains. Question in the back? We are working, but yes, there's very good evidence that we're seeing shifts in elevational aspects of where plants are occurring, right? We're seeing shifts northward of plants, right, going with that increase in growing season length. We're seeing increases in non-native or other species coming into the system. They're much more competitive. A couple reasons, right? The natives that are there in most of our systems have a pretty good window of memory of when it rains, right? And when that is shifting, they're not able to quickly move. And so there's an open niche there early in the growing season. So if you can fill that niche, if you're an early emerger, you can get out there when it's warm and a little bit of moisture, and guess what? There's probably some available soil nitrogen. You can grow quickly. You can beat the natives or the remaining plant community to the punch, right? So you can kind of wiggle your way in. And so we're seeing that occur with a lot of these perennial forbs that are deeper tap-rooted, using this winter precipitation in the previous fall to get a head start. So we're seeing cheatgrass. All right? Our good friend cheatgrass is one that's really starting to come from the Intermountain West, popping over into parts of the Great Plains. I think because of this, we're seeing that shift, and there's an open niche. And so it can get started and get going. Disease and everything, yes. We're starting to see mountain pine beetle. You know, that was a tremendous amount of aspect. And if you look at people from the APHIS, Animal Plant Health and APHI Inspection Service, their models really showcase this with increase in temperatures, long growing seasons. The vectors and the ability to transmit disease is going to be rampant. Right? So how do we deal with that sort of thing, both not only in terms of infectious disease, but just flies and other things like that in herd management? I think there's another question back. Something's shifting, right? And so it's much easier to see when you've got that really gradation in elevation. We see that in a lot of the northern Great Plains with the Rocky Mountains. There's another question. Oh, over here. Mm-hmm. And you can't utilize it. Yep. Right. Again, this is predicting out to the middle part of center, right? And you're going to see that. I mean, these are based on pretty coarse spatial scales. They're trying to capture it. I'm sure, within this, it's not everybody in this area is going to be drier. There's some orographic effects. But I think the nice point you drive home for me is the business as usual mental model that we have as producers is going to be markedly changed. And we're going to have to be very flexible and adaptive, right? Because what's happened in the past is not what's going on now in terms of that earlier growing season, changes in pest pressure, and so forth, and change in species composition. Mm-hmm. That's right. Any other questions? I really appreciate. Oh, back again. A great question. A lot of that's ongoing now. Looking at how plants can move. Problem is when you start to talk about individual plants, is then you throw them into that complex plant community. And so I think that's the frustration we have right now is how do you look at what the assemblage of plants might be, and which ones might be coming in. We know that there's some players that are going to be a problematic. Cheatgrass, spotted knapweed, leafy spurge, Dalmatian. In our country, in the northern part, all throughout here, it's largely deep-rooted forbs or trees. Eastern red cedar is another one that's taking advantage of this and this, right? Because our natives are not growing at that sort of time, and so by the time they get up and going, there's a lot of water that's been used by these other species. And they're usually fast-growing plants that grow a lot, can be highly palatable at times, but a pretty narrow window of utilization. And a lot of our management systems are set up not to take advantage of that yet, right? Because we don't want to put cows and calves out on it, because we want to keep them around the house, snowstorm. Maybe we're going to a public grazing allotment, and you can't get out there till May 25th or whatever the rules might be. So we're having some limitations, and frankly, in some areas, we're getting behind the curve, right? So we're losing the game. We need to be out there grazing to give us a better chance to keep the natives going, and we're retrogressing back and forth. So those are some things I think that, we need this flexibility in management to be able to sit there and say, if it's going to be like that this spring, how do we get out there and take advantage of that and accelerate the use of some practices that might be beneficial this year, but don't get trapped because next year it might be totally different again. Okay. All right, so hopefully what I've been able to do is to kind of give you a backdrop of what's kind of driven the system in the past historically, right? Grazing, drought, fire in some situations, and then give you kind of a retrospective of the last 30 years and maybe why producers in certain areas have changed some management and maybe why they've kind of got a mental model of this is the new normal that they're operating under, but it might be a false normal, right? Not built upon long-term data, but based upon what's happened the last 30 years. Tried to showcase what the best predictions are at this time, All right, and we'll continue to update these on what the middle part of the century is going to look like and some spatial patterns there. And I think there's some things we need to look at in terms of areas that are going to need a lot of concentration for adaptive management. Some other areas, again, that might be, quote, winners. I want to spend kind of the rest of the time looking at, so how do we become much more flexible and adaptive in our management? Right, it's easy to kind of get in the rut of Columbus Day management, if you will, put cattle out, go round them up later, do business as usual. We signed a 5-year contract, be it a CSP or EQIP, and we kind of get locked into that sort of thing. But how can we look at practices, approaches that might be very open to being messy, if you will, but advantageous in those years when we need to take advantage of what's going on in terms of landscape changes. So this is, again, kind of driving back. This is a place on our research station in northern Colorado there. This is just 6 shots, 2 of which are the same year, but the same sort of area. This is 2000, very dry. This is 2002 in June when we're out there trying to do our sampling, walking on crunching grass. It rained 4th of July. This is about the 10th of July, so about 2.5, 3 weeks difference. We markedly changed. Right? So we went from a situation where dry, desperate situation, what we're doing with cattle, to now we've got some green grass and we're hopeful. How do producers handle that? Then we got years that bounce around like this, right? So this is pretty normal. Look at the amazing amount of forbs that happened in that year. 2009, a lot of spring forbs and a lot of needle and thread. How do we take advantage of that situation? And this, I think, was in 2008 or 8 probably. Again, a totally different type of plant community emerging that year. But this is just on a site-based. So if we're doing static management, what we're doing here is pulling cattle off. Gosh knows if we can go back on. And then in these years saying, we got a lot of extra grass. Right? Should we take advantage of it? What are we going to do with it? So we're playing the seesaw balance game with it. Again, driving back home, so how do producers deal with this sort of thing, and how would you deal with this when you start to look at conservation and management plans? Right? If this has become the new normal, right, how do we deal with that? Because averages don't matter in that case. Right? If we do average management, we're still back to the take cattle off, put cattle on, take cattle off, and a lot of folks don't have the operational capacity to do that sort of thing. So managing this and being able to set animals out there to take advantage of those good years and to not degrade the rangelands in the bad years is really a difficult situation. So here's some things, we talk to producers and they tell us here's some things that the progressive ones are doing and the academics are thinking about, but how do we get flexible in the situation? Well, if we're all cow-calf, about the only flexibility we got is to sell animals, right, or move them. Because a lot of producers are really reluctant to sell that genetic cow herd base. They've built it up, they've got the animals matched to their environment, and that's a difficult thing to do. Can we just reduce the amount of these cow-calves down to some lower level and add yearlings in there, much like we used to do? A lot of producers used to do that, retain their steer calves, and then they use those as the floater animals. It got dry, they sold them. If it stayed wet, they grazed them. And they might have even bought some more animals. Is this an enterprise that might provide enhanced reduction of risk? Right? Are we able to take that financial ability to take the markets now because of how we can do things and perhaps give us an ability to make even more money when it's wet and lose less money when it's dry? Right? We don't have to sell that base cow herd if it's really dry. We just sell the yearlings off. What about other grazers out there? Sheep, goats. They don't have to be a permanent part of the place, of the ranch or landscape, but they might be occasional grazers. Right? We can rent goats and sheep to come into the place and maybe be that one-time grazing event that helps us in terms of weed control, right? Or in case of brush control or something. And there's emerging markets because of ethnic changes in the U.S. where these might be targeted beneficially because we've got a market for the meat right there locally. So I think there's some opportunities there as producers start to look at, is there a way of an enterprise, especially for younger generations, to come back into basically a cow-calf area and say, maybe I could be the one that has a roving sheep herd, right? Or be a goat person that takes these around the landscape. in some sort of way. So I think there's some nice entrepreneurial type stuff that can be done on this, again, in a very adaptive manner. When are we going to calve? You know, a lot of producers traditionally are fall calve, some are spring calving, I mean, others are fall calving. Are they going to be both? I mean, one of the things we're running into now is genetics are so darn good that the producers that are calving in the fall, the calves coming off in the fall now are just too big to carry over the winter to be able to come back the following spring to put in grass growth onto them. Right? So do we shift that sort of thing, or do we shift it later in the growing season? Right? Or if we're going to have an earlier spring, do we shift it further earlier because that's when we need to have those cows out there in that early green up. So this is going to be a decision that's going to have to be made pretty local and matching, again, the calving season to that local environment. I think this is a really interesting study that's been a little bit overlooked. Alan Terrell, who's an economist down in New Mexico State, works a lot in rangelands. But he put together this sort of strategy and published it in 2010. You know, this is a sensational headline that any producer likes to see. And when we talk about this with producers, their eyes light up because it matters to them, right? Dollars in their pocket. If you can be flexible stocking, and here's a caveat, high quality precipitation forecast. So we really need to get that thing hopefully enhanced. We can double economic returns, right? This isn't some fancy game and management. This is essentially just trying to match forage availability with what you've got in terms of animals. So we worked through this. He's got stocking rates, and this is for a typical ranch in northeastern New Mexico, but I think it would apply across most of the rangelands. Conservative stocking rate, we're taking about 35% of the forage being produced. Long term, kind of being very sustainable. And if you're all cow-calf, so you put all your forage cow-calf, you have no yearlings, on average over a 30-year return, about $55,000 in annual net returns to your ranch. Okay, so that's a pretty decent return. If you go with this conservative and you just add some yearlings in, still staying at 35% use, and half the forage now goes to the cattle or to the cow-calf herd. Over those 30 years, about half the years you'd have to buy yearlings, right? Because you've got excess forage. You don't have to sell cows and calves in those dry years because you've already got that sort of built-in flexibility. In general, over those 30 years, you're making about an additional $8,000. So $8,000 over 30 years, $240,000. Probably not a bad take-home paycheck there. With, again, just a simple change in management strategy here. He says this is what most producers can and probably would do if we went to the ability of going very flexible. So you're willing to take the risk. Instead of set stocking at 35%, you're willing to match forage production with animals out there. Again, with high precipitation forecasts, that theoretically is possible. If we just have all cow-calves, again, 100% there, and we're able to match those highs and lows, right? We go from 55,000 to almost 70,000. So that's a nice increase of about $15,000 just by being able to match forage production, because we're not doing the buy, sell, sell at the low period because of drought, and buy back when they're expensive. If you get really aggressive and you go flexible with cows and calves, you reduce the cow herd down, but you buy a lot of yearlings when you need them. $115,000 return on an annual basis. $60,000, you doubled your money. So I think that's the possibilities out there, right? The caveats are the producers willing to reduce the cow-calf herd size down to some baseline that they're willing to have for good genetics, and they'll play the forage with the yearlings, and can we get decent precipitation forecasts so we can start to actually get ahead of the curve and buy yearlings when we need to and not have to be so reactive that we're at the last minute buying or selling them because they already got them on board. So this is, I think, utopia, but I think it's something that we need to be looking at as precipitation forecasts get better, as producers start to look at alternative ways to make more money. Right? I mean, I'm not sure how many producers out there are willing to say, I'm just going to give this up without maybe even thinking about it, right? Especially as they look at different business models, as they bring new generations on. here's a way to really enhance the rural livelihoods and rural sustainability of communities by really not doing too much other than just getting us a little better forecast and being ability to make changes in the structural of the operation. Any questions about this? Question. Great question. So if you look back at what's happened in the last 30 years, most of that increase in precipitation is the eastern Great Plains, a lot more stable cow-calf production coming there. You also look at the southern Great Plains down at Chuck, and the predictions for that area to be less precipitation, hotter and drier. Where are those yearlings coming from? The southeast. Instead of going to wheat pasture, maybe they go to western rangelands. So I think what you're going to see is a much more mobile livestock sector where animals are moved back and forth across this. And so now it's going to become a game of matching up phenotype, physiology, right? What kind of animals do you want long-eared animals out here in California grazing this? But you see this, I think, already emerging. In the 2010 drought, 2011, a lot of cattle left Texas. They went north. South Dakota and Nebraska and North Dakota, tremendous increase in cattle, right? Because they've been drawn down and they've got a huge amount of capacity. Cattle in California, whoop, they went east, right? So you saw a lot of cattle moving. It's simple now. We can put them on a truck and they're mobile. So I think what you're seeing is some of the producers getting out of the aspect of being very sedentary and looking at, this is my place, I just have to look at it as my only place. I have options. And I think you're also seeing some larger ranch and ranch enterprises looking at buying operations spatially separate, different ecosystems, maintaining a pretty large base cow herd, but then moving that cow herd as needed because of drought conditions. So if it's dry in Chuck's part, you move them to the north, maybe you move them west, so forth. But they have got their built-in own drought strategy, and they've got a bottom line that says we need to produce 10, 15,000 cow-calf pairs. But that's a great question, because if everybody does this, right, do we have enough stockers, right? Or do we looking at dairy industry, alternative grazers, sheep, goats, so forth? But I think this sort of thing, we actually need to figure out a way to utilize that available forage when it's out there and to not use it and not degrade the rangelines and take off that cover and keep what we can be when it's dry, because we know we're going to get an extreme event that probably follows that in terms of precipitation. Chuck?
What you said, moving these animals around, that's good. But how do you recondition these animals for those different climatic forage areas? Because wheat's one thing, that's no reason. And there's a big issue with just not protecting the wheat. Even worse when you stick an animal that's going west.
Precisely. So yeah, so from the animal science, from the physiology, from the diet quality, how far can we move those animals, right? We see that in the Great Plains. When we go east of Missouri, our gains fall off. They're not used to eating fescue. And we got problems with endophytes, right? How far north can we move them? Seems like it worked pretty well in 2010, 11, moving those cattle to the northern Great Plains. Now, I'm sure they probably were looking for a barn or some good shelter to calve out in. They weren't used to that. How are we going to match that? So yeah, so if you've got a desert environment of Arizona, you're not going to take a black baldy cow from eastern Nebraska and stick her out there. You're looking at a train wreck there. But you might be able to grab something from the southeastern part of the U.S. and move there and make those transparent. So I think we'll see some sort of that, and we might see some sort of genetic aspects of this from the animal side of what's the right grazer. Maybe it's not cattle, maybe it's goats. We just need something out there to harvest that. Or it might be something non-traditional. Again, a lot of dairy steers, right? A rapid market. Could we move those quickly, graze it, and then they go back to some sort of confined feedlot situation to finish it out? So I think there's a lot of possibilities out there. It's just I think we've got to get out of the mindset that I own this ranch, and that's my only forage base, and unless I have to do something here, I'm stuck. I think there's a lot of capacity. Cece. Mm-hmm. All right. And there's an economic return. They're doing it for a reason, right? That's a great point, CC. You know, one of the things that we try to do is, who are those progressive folks in our area, and visit. How are you doing this? Why are you doing it? Right? Because this is not easy. It's not. There's not a cookbook for dummies of moving animals around. They've learned some strategies. They learned how far they can move animals. They understand the economics, but they're also operating that as a full business. I think, CC. Right? So they understand, putting the pencil to it, that there is a reason that you can move animals and make money on them, even by moving them, versus leaving them sedentary and bringing feed to them. Right? And so they're on the much more the aggressive strategy rather than the stay back and kind of hunker down mentality. And unfortunately, there's a lot of those producers where I've never done that. You know, I don't want my cattle to leave here. I don't want somebody else's cattle to come in, and I'll just kind of do it. And unfortunately, there's also sometimes some government assistance programs that essentially make that work for them on that end. Question? But we took care of that. It's down to 2, right? We haven't seen that because guess what? With $4 diesel fuel, we're seeing $3.50 calves, right? $2.50 for yearling steers. So it's proportional. They're still making it work, you know. And these guys, I mean, CC's right. They're really front-loading folks. When those steers are bought and moved, they're already looking at options and holds and marketing strategies. This isn't, we're going to buy them and then cross our fingers and we hope that when the market comes and when we get ready to sell, it's a good day. They've already got things in place to make sure that they've got a bottom line strategy. So, you know, ag marketing, you know, ag economics, you're seeing those sort of producers really kind of take those sort of options and move with them. Okay, keep rolling because I think, so I think getting back to how do you deal with not only livestock production, you've got these other conservation objectives out there on the landscape. Those of you who've seen either David Augustine or myself present the last couple days, we've got a new study there in Colorado, and Ken Tate's got a parallel one up here at SF Rec, where we've taken a chunk of rangeland and brought in some stakeholders and essentially said, you provide how you want to manage it for multiple goods and services. You tell us how it should be managed in terms of practices. We'll do the monitoring. Can you beat what is business as usual? So in our case, we brought in 10 stakeholders. We got 4 ranchers. We've got 3 land managers, Forest Service, NRCS, and Colorado State Extension, and 3 environmental groups, conservation groups, Rocky Mountain Bird Observatory, Environmental Defense Fund, and Nature Conservancy. That group was given all the blue pastures here. These are each half section, so they got 3,200 acres. Parallel with that, the paired yellow pastures, another 3,200 acres. So 10 square miles, 6,400 acres is their research project to play with. We told them, as a group, you have to work through the process of what are your outcomes, what are your objectives, and what are your strategies. So outcomes and multiple goals. They want to be profitable. They want to change composition and structure. Wildlife habitat. To me, it looks like, hey, we're writing a conservation plan, right? This is what we're after. And we're seeing this sort of synergy really take place that livestock folks are learning from the conservation group. Conservation folks are really understanding the difficulties in livestock management, when animals need to be, nutritional planes, etc. And then moving around on the landscape, I think, in a very adaptive manner. This is some work, I think it maybe gets back to what Cece said, on some of the inherent sedentary aspects of ranch management. This is in Wyoming. So we surveyed 3 300 plus producers up there and said, how do you handle drought? Right? And so you can prepare for drought, and then of course you respond to drought. And some of them are stocking conservatively in their mind. They're resting some pastures. They're doing some grass banking with some sort of maybe a third party there actually holding grass back that can use emergency situations. 28% are using livestock, and only 16% look at the weather or predictions and forecasting. So I look at this and say, there's a lot of opportunity out there, right? If we want to be much more prepared, maybe we ramp this number up because we know that we have a lot of drought years and we usually limit in forage. Only 28%, these kind of cutting edge ones, are using livestock structural changes, so there's more opportunity there. And I keep hammering on my weather service and NOAA folks to say, here's the impact. If you guys want to have impact, help us. Right? Get those predictions up, at least within a reasonable risk that producers will say, it's not perfect, but I will make a management decision based on that because I know what the parameters of risk are. Unfortunately, most of the times, we're in this situation, and then it's like, oh my gosh, it's dry. What do we do? Everybody's selling herd. Everybody's weaning calves, selling everything. Well, typically, the drought influences low market prices, and so it's a double whammy. You got no forage, you got low prices. You're trying to find feed, you're trying to rent pastures. Those are getting expensive. You're moving around. You're trying to put them in a feed yard, which costs you. You're hoping that there's some sort of government assistance. But here's maybe a way to get out of the dogma of this is business as usual. How do we get around this and be much more adaptive, right? And this changing the structure, less cows, maybe more yearlings or different enterprises. We'll talk about here how we utilize landscapes in general situations because we got a lot of people asking us to do different things. So it's not only your ranch anymore, but a lot of times you've got all kinds of folks interested in what's going on in your place. So how do you get human dimensions? I mean, this can be all the way from social aspects to political aspects, regulatory aspects, but there's a lot of players now on the landscape looking at how we manage rangelands. And then we got all kinds of things that we should be looking at rather than prescriptive. How do we make them adaptive? When should we burn? Right? How do we get rid of that fuel risk? At the what time? How do we enhance that forage quality? Right? So if we know if it's getting greener earlier, how do we get the cattle out there? What type of cattle to take advantage of that sort of thing? If you're in an area in the Eastern Great Plains, you got a lot of this, right? Tremendous amount of acreage being planted for corn because of ethanol. They're utilizing those sort of residues. How do we incorporate that into the grazing plan, right? Because this is a lot of forage. In fact, I think Nebraska's just recently calculated they could double their cow herd if they could figure out how to use all the corn stalks in that state. So talk about really ramping up production and taking advantage of a free resource, if you will. Now, how do you handle this in terms of manure management? How do you handle this in terms of residue management and so forth? But in eastern parts of Nebraska, there's a lot of corn ground being not utilized here in terms of forage resource. And then lastly, there's a lot of technology. I've got the old dumb phone. I've got a smartphone. There's Surface Pro 3, iPad, whatever the number of the thing is now. And that's just within the recent couple of years, right? So now we've got the ability, this is some GPS collar work. We've got collars on animals. We know where they're going. We know what they're doing, if they're grazing or not. We've got leg monitors on, so we know how many steps they're taking. We know the amount of energy they're expending. Right? We got satellites tracking everything and everybody. We've got planes flying over. We've got drones flying over. We've got place-based GPS stuff. That's information. Right? It's at our fingertips, and how do we utilize it? The crop producing side is really way ahead of us. Everybody's got a GPS tractor except for the old guys like me. He's got an old tractor, but everybody else they get in there and they really don't need anybody in there other than just make sure the thing's running because it's all GPS. The rows are nice and straight and everything. How do we handle this in terms of rangelands, right? Can we be grazing smart? I mean, think of the possibilities if we could corral those animals without any fence and move around because we just kind of give them some sort of signal and say, don't go down that riparian area. We want you over here today, all right? Oh, we're about out of grass, so we're going to move you over here. And so we've got technology beyond belief. We've got unmanned aerial systems. We've got drones flying all over the place. We've got Google Maps, right? You pull that up, and you can see exactly what's going on in your place. You don't even have to go out and check your cattle hardly anymore because you can see them. You got phone technology. You can shut your garage door in Cheyenne, Wyoming, by pushing a button here in Sacramento, California. We can GPS track those cattle. We can do virtual fencing. Can we really be precision grazers? I mean, that would be the ultimate, wouldn't it? Precision farming has really gotten to the point where we can do what we want to do. We put the right variety down. We put the right amount of seed. We put the right amount of fertilizer, the right amount of water. What if we could do that for grazing instead of just saying, yeah, we took about half, left half? Well, maybe we won't want that in an entire pasture. We've now got all the genomics data, right, for all the major species. Anybody and everybody can play with it. Talk about a tremendous resource. What's going to go on in terms of genetic aspects of that rumen and animals? So we've got forage quality problems. Guess what? Can we do some things from the genetic side, right? Can the animal scientists help us in terms of saying, we know we're going to produce more forage, but it's going to be lower quality. Help us out here. And then, this is the ultimate, right? So we get NOAA and the National Weather Service to give us seasonal temperature and temperature predictions spot on, right? We've got real-time soil moisture satellites going up this month, right? They're going to give us twice a day what the soil moisture is out there across the world. How do we integrate that? We've got satellites that can give us plant growth off of GreenNess or NDVI, and correlate that then to forage quality and quantity out there. So now we're sitting at the computer or on our smartphone saying, we've got all this information about my grazing area, my ranch, my allotments. Decisions ought to be easy, right? Technology should be our friend here, and how do we enhance this in sort conservation planning, technical service providers, and again, thinking a little bit, pardon the pun, outside the box, right? We really need to capture this because Google and everybody else is doing it for us. We just got to figure out how to work with them to help us in this sort of situation. So with that, I think I'm finally done. Oop, decision making. Okay. Happy to take any questions. Where we've been, this is actually on our ranch. This is in a Colorado ranch, Old Sinus, and then that's our little one back there that we hope eventually will take over the ranch and run the place for us.